I can't factor it with the little 2x2 grid, so I'm going to have to use the P's and Q's. So remember, the P values are plus minus 1. All the factors of 80. 4, 5, 8, 10, 16, 20, 40, and 80. And the Q values are the factors of 3. Plus minus 1, plus minus 3. So the P over Q's are going to be all of these numbers over these numbers. Okay, so you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 plus and minus fractions. 1 over 1, 1 over 1, 1 over 3, 2 over 1, 2 over 3, and so forth. So, let me write it down. So it'd be plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus 4, plus or minus 4/3, plus or minus 5, plus or minus 5/3, plus or minus 8, plus or minus 8/3. And just keep going. And plus or minus 16, 16/3, 20, 20/3, 40, just forgot plus or minus, 40/3, and 80, 80/3. Okay, very long list. So let me just divide it here. So these are the numbers we have to choose from. And if there is a rational zero in this polynomial, it's going to come out of this list. Okay? So let's start off with 1. So you do 3, negative 5, 48, negative 80. So you just do the synthetic division. This could be negative, 34. So obviously not a 0, so then we try 2. Same number, same order, it's the same polynomial. So 3, 1, 50, 100, 20. Now, if you remember the intermediate value theorem, that tells you that if you get a number, a value below the x-axis and another one above the x-axis for the function, then that means that there has to be a 0 between those two numbers. Now look at 1 gave us negative 34 and 2 gave us positive 20. So that means that there has to be a 0 between 1 and 2. There has to be. Okay? So of all the values on my list that are between 1 and 2, that would be 4/3 and 5/3. Okay, those are the only two. So I'm going to try those. Okay, I'm going to try 4/3. Okay, so bring down the 3. 3 times 4/3 is 4, and then it starts to not look good anymore because negative 1 times 4/3 is negative 4/3, and it's just going to get more fractions. You're not going to get rid of the fraction. So 4/3, I'll stop right here. It doesn't work. I'm going to try 5/3. Let's see what happens with that one. So bring down the 3. That gives me 5, 0, 0 times a 0, 48. 5/3 times 48 is 80. And there's your 0 right here. So what do we have left? 3x squared plus 48. So, move this up a little bit. 3 x squared plus 48 times x minus 5/3. So that's the factored form. Now it's not the way they want it as a linear factor, right? We have to factor this a little bit more. So I can factor out a 3, like that. So that leaves me with x squared plus 16. And then this, you know, just like there's been a couple examples that were problems that we did like this where it was a sum of two squares. So this could be rewritten as 3 times x minus 5/3, x plus 4i, and x minus 4i. Okay, so here it is in factored form, linear factors. So the zeros are 5/3 and plus and minus 4i. Okay, so here, was it f of x? Yeah, f of x. So this would be f of x equals that. Alright, so for 32, the p-values are plus and minus 1 and plus and minus 29. So not too bad. The q-values plus minus 1. So p over q is just basically, it's these four numbers. Alright, now look at the polynomial. There are no negative coefficients. Everything is positive. And remember, we're looking for the zeros, right? We want to find the x values that make, oops, let me switch the color. So 0, this is what we're looking for. We're solving for x so that we get 0, right? So think about it. If all of these are positive, and I plug in another positive number for x, even if it was 0, I wouldn't get a 0, correct? So for that reason, I won't start off with positive 1 or even positive 29. I'll start off with negative 1. Okay, because that's the only way I could possibly get a 0. So put the numbers in there. Oops. So I get 1, negative 1, 10, negative 10, 29, and it worked. Okay? And so now I have this polynomial, this quadratic. It doesn't factor, so I'm going to have to use quadratic formula. So let me set it up. So we get this right here, so x equals negative 10 plus or minus, and so when you simplify the radical, you get negative 10 plus or minus 100 minus 116 is negative 16 over 2, so then this is negative 10 plus or minus 4i over 2. Factor out a 2. And so now I can reduce the 2's, cancel them out. So here are the zeros. The zeros are negative 1 and then negative 5 plus or minus 2i. So these are the 3 zeros. Now to write this in factored form, as a linear factor form, you would put f of x equals x plus 1 and then x minus negative 5 plus 2i times x minus negative 5 minus 2i. And then you would just distribute the negative in each of the factors with the i's. Plus 5 minus 2i, and then x plus 5 plus 2i. Alright, so number 35, I'm going to have to use the p's and q's again. So the p values are your factors of 16, plus or minus 1, 2, 4, 8, and 16. And for q, it's just plus minus 1. So that means that p over q is basically the p list, right? Because since q is plus or minus 1, it's this list right here. Alright, let's get started. Let's start off with 1. And again, I'll use 1 because there's pluses and minuses right here. So you can start with any number, so I'll just start with 1. Okay, you set it up with synthetic division. Bring down the 1. 1 times 1 is 1. -3, 5, 5, -11. It's not going to work, right? So you try 2. Try the next number on your list. 1, -4, 8, -16, 16. Bring down the 1, 2, -2. -4 is 4. 8 is -8, and then -16. So we found it. We found 1. Okay, I still have a cubic function, right? It doesn't hurt, or it's always a good practice to try the number again, because the multiplicity of that 0 could be more than 1. So, and remember, we always use the reduced polynomial. Use these numbers. Don't go back to using these numbers, okay? Once you find a 0, use the new polynomial. So bring down the 1, 0, 0, 4, 8, and 0. So here we found it. So this means that g of x is x minus 2 squared, because there's 2 of them, and then x squared plus 4. So this being the sum of 2 squares right here, we're going to do what we did in previous problems, where you think of this as x squared minus a -4, and then you look for the square root of -4, which is 2i. So then you would rewrite it as x minus 2 squared, and then x plus 2i, x minus 2i. Okay, so the zeros are 2 and plus or minus 2i. Alright, for 38, they want you to find the zeros, write it as linear product of linear factors, and then give the x-intercepts. Okay, so replace this with 0. This is again a quadratic that does not factor, so we're going to use quadratic formula. So that's 12 plus or minus, now 144 minus 136, because 4 times 34 is 136, gives you 8. So remember, 8 is 4 times 2, so the 4 comes out. So you're left with 12 plus or minus 2 radical 2 over 2. We factor out a 2. So now I can cancel the 2's right there. So the zeros are 6 plus or minus radical 2. Okay. For part B, they want you to write it as product of linear factors. So you're going to write f of x equals, because it's a complex 0, you have to use the brackets initially, like this, and then x minus 6 minus radical 2, and then simplify this by distributing the negative. Like this, and here it is, f of x. And then for C, they want you to identify the x-intercepts. So because these are real numbers, 6 plus and minus radical 2, plus or minus, these are real numbers. So we just approximate them on the number line, and this is where the graph is going to cross the x-axis. So the x-intercepts are 6 plus or minus radical 2. Alright, 41. This one definitely, I was going to have you guys skip it after I solved it myself without a graphing calculator and without, any additional or